If you're playing God for a day, whether it's Mrs. or Mr. God, it doesn't really matter. This would be the ideal soil. So the mineral part of it is your sand, silt or clay. That's what you've been given, but you need to know what you've got and what proportions, which we'll look at in a minute, because they all interact with the environment differently. These are some of the crucial bits that within the soil you need to maintain 25% air, 25% water. Quite difficult to achieve, but a bit of thought, planning, and it can be made to happen, because without that you will not have profitable crops, and then we won't be saving the planet. That's the other thing to think about, ladies and gents. 25 mil of water is an inch in old money. A hectare weighs 279 tons. If you haven't got the structure of your soil right and allowed the crop to interact with it, then you've got a very compacted environment that definitely won't have 25% air, 25% water. Unfortunately, I started working with a farm that's got a very high magnesium content in its clay, so the soil compacts very quickly, and that was 3 years ago. He only ended up with, across the board on quite a big acreage, I won't tell you how much, but it's into the 4 figures, of less than 3 tons a hectare, 3 tons an acre of wheat yield, which is not big or clever, but he was extremely pleased because he'd made a profit. Just need to be thinking about this. We all know the soil texture triangle. You need to find out what soil type you've got, match the crop to it, and then use that information to get the correct machinery to manage your soils. But if you don't know what soil you've got, you can't make the right decisions. This is the other thing that's really, really important to think about, and it moves on to what main point of what I want to talk about, but I could talk about it for hours, so I've only got half an hour. Sand, it's dead and inert. There's no chemical charge to it. Whereas your silt and clay particles have a negative charge, so therefore they will hold on to the positively charged nutrients that we want, the cations, calcium, phosphate, which is an anion, but calcium, potash, magnesium, all those crucial factors we need for our plant to grow. And it's why historically we know clay soil always has the greatest potential for yield. It's always a pain to manage, but has greatest potential for yield. If you think of that grain of sand, and you can get 33 particles of silt in that grain, 333 particles of clay, you then take all those out and put them in a straight line. That's a huge surface area of charge that then works like magnetism in the soil. That bit at the bottom, I can't tell you how important it is. It's not my world, but it's absolutely vital. I put this up because we really need to think about this. I know you're converted, but it always gives me a bit of a giggle because the young farmer who was trying to incorporate all his organic matter was failing miserably. His grandfather, who's only just allowed to drive, bless him, drove past, got out of the car, got in the tractor and showed him how to do it. But we need to be full inversion tillage if you do have to plough. They only ever plough, I think, 4 or 5 years in, so 1 year in 4 or 5. But to incorporate the organic matter back in the soil is quite important. We know all of that. This is some numbers that probably make you think. This is what you want to achieve. 43% increase in water infiltration. That's because the roots are doing the job for you. If you've left the roots from the previous crop in the soil, you've got those channels. The new seed can follow that channel. Air can follow that channel. Water can follow it. The whole environment's working for you. You get an increase in water retention because you've allowed the soil to restructure itself. Earthworm biomass increases. I'll talk about the worm species, where they are and what they do in a minute. This is the important bit, that because you've allowed the soil to build back up to the level that it used to be, because gramineae species were the first species that colonised the planet, which is all the grasses, and obviously wheat and barley are grasses. When arbuscular mycorrhizal fungi interacts with the roots, it produces stuff called glomalin. That glomalin is a protein that it needs that releases more phosphate from the soil. Because phosphate is an anion, has a very high negative charge, it's stuck in the soil and often doesn't come out very easily. Get the plants to do the job for you. Saves you a fortune. Tractability in soil working. If you're going over your land half a gear quicker or even a gear quicker, I've got one of my farmers, and in fact that's the one that I was just talking about earlier where all the rainfall had. He measures and manages exactly the working power, the diesel output and absolutely everything from his tractors, and he said the saving in money that he's made over 3 years has easily paid for me. We're not letting so much soil run off. If it's not running off, then it's not going down the drain, not causing a pollution incident. More importantly, the soil that runs off is taking all your nutrients with it. That's important as well. We're not losing so much nitrogen either down the drain or volatilizing back into the atmosphere. That's the important bit that we need to get to about saving the planet. You get an annual increase in the carbon capture. In other words, the level of carbon that the plant wants to use what it wanted, what's left over is sequestered in the soil, which is what we need to be doing. So just a few photos of, we've looked at plenty of soil pits, but just think about what you've got and find out what you've got and what it looks like. This is really interesting. I wish I'd had a digital camera. This is from, early 90s I think now. Basically it's triticale undersown with white clover. The increase in productivity in the soil was really good. The farmer thought I was absolutely mad, but gave it a go. Well, triticale is a bit of a pain to sell because when you try and sell it, merchants always tell you it's worth nothing and knock 5 quid off a tonne. But the gross margin from that crop was fantastic. We let the sheep in afterwards, put another copper triticale in, and fairly spookily, we didn't have to do much to it. Virtually no pesticide input at all. Just need a quick bit of reminders about earthworms, what they do. There's 3 basic types of earthworms. You've got the epigeic, the little red guys that live near the top. A bit further down, you've got the endogeic guys that are pale, a bit bigger. They go horizontally. But you need to start getting quite excited when your soil starts generating the anisecic, excuse my pronunciation, they're the ones that go vertically. They're about as long as a pencil, dark black head, red body. They're also the ones that, when it pours with rain, we tend to see on the roads. So if you see them on the roads, don't run them over, put them back in the grass verges because they're creating air pockets in the soil that are allowing the microbes to work. Organic matter we know about, but the thing is that organic matter on its own isn't actually the answer. That's got to be converted to humus. It says at the bottom, take up to 20 years for that to be converted, so we need to be starting to think how we can achieve that now. Soil-borne microbes absolutely vital, particularly our arbuscular mycorrhizal fungi, because when a plant root grows, it has an exudate on the outside. It's a slime trail like a slug. It's full of amino acids and sugars. The microbes in the soil feed on that and in return produce masses of hydrogen ions, which I'll explain to you in a minute, release the nutrients. So instead of being bound in the soil, they're in the soil solution and then can be absorbed by the crop. This is what we want to be trying to achieve. It's measured by the cation exchange capacity of the soil. Will help everything to start with. If you haven't got soil microbes in the soil, and you can now actually buy arbuscular mycorrhizal fungi to put in the soil, there are probably better ways of increasing your soil microbe levels. And I won't talk too much about that because steal other people's thunder, but you can't always do everything, and sometimes being able to get something out of a box does make a significant difference, providing you're doing everything else in a fairly holistic approach as well. So just to remind ourselves what we do and what the plant needs to actually work. Fairly spookily, if we haven't got rain, there's nothing dissolved in the rhizosphere, which is the root zone for the plants to actually absorb. Australia are doing some pretty extraordinary things at the moment. They're changing the genetic signatures that are in the stoma. So basically when a plant absorbs nutrients through the roots, it goes up through the plants, goes up the xylem, moves around in the phloem, gets distributed around the plant, and the water that isn't required is evaporated out the top by evapotranspiration. The guard cells are the things that monitor the environment above ground and say, actually, it's too dry, we need to retain water in the plant and close. They're ridiculously slow to work. They're not very good photoelectric cells at all. Australia has done a massive program after the last 5 or 6 years to actually increase the speed of that, to retain more water in the plant, because without the water in the plant, the nutrients can't be absorbed and move around the plant. All of the things we know, but actually helping the plant to achieve that is really important. This is more of my world. I've got a couple of slides that hopefully explain it to you. The most straightforward thing to think about is think magnet, because the rhizosphere in the soil is predominantly negatively charged, but all the cations that we want to feed our plant are positively charged. So if you think of that area around the roots is predominantly negatively charged, that's your clay, that's your silt, it's your organic matter. Sand doesn't have a charge at all. And then you've got your positively charged nutrients in the soil that are bound onto that negative area. Depending on the positive charge it's got, it depends how much it's bound in the soil. And this is a really, really important point to bear in mind, ladies and gents. You can measure that and go, oh, brilliant, we've got loads of it. But unless you help that get out of the soil by having a healthy crop, you're a bit stuck. The major anion, as in negatively charged nutrient that we need, is phosphate. As you can see, it's got quite a high negative charge, which means it sticks like to a blanket in the soil, because it binds on in preference to all the other cations that are in the soil and doesn't come out very easily. So if you've got that mental picture of we've got everything in the soil but it's stuck there, without the roots growing, and without the roots growing effectively and providing the exudate, slime trail on the outside, feed the microbes, that situation will just stay there and you're not going to make money. So if we take that as our first situation, that's the slide we've got now, but the clever bit of nature, for want of a better expression, is it's a very symbiotic process. That slime trail that's got the amino acids and sugars in feeds the microbes. In exchange, the microbes produce hundreds of thousands of millions of hydrogen ions. Yes, they're positively charged, but they're slightly acidic. So once they've produced the hydrogen ions, that then breaks the bond for all the nutrients that are in the soil to then be liberated in the rhizosphere, in the root zone, in the water, and be absorbed by the plant. If that root is not growing effectively, that won't happen. And that's the bit that you guys need to achieve to make money. Because once you start doing that and interacting with the microbes in the soil, as I said earlier on, the reduction in input costs are dropping year on year on year. Yields are stabilizing and in most cases increasing. Not dramatically, but increasing enough to be making a difference. Tractability working, movement power, everything that we're doing to establish the crop is reducing. I'm getting quite a few of my younger farmers complaining because they know how to take their wives on holiday more often, or in the other case, wives take their husbands on holiday, but more time, more money, because the soil and the crop are interacting properly. That's really important to find out about your cation exchange capacity and make it work for you.